my dear students. Today we are going to continue our discussion on chapter 2, which is chemical analysis. We are going to continue our discussion on identification of acidic radicals, and we are going to continue our discussion on the group of concentrated sulfuric acid. We are going to talk about the last anion of the group of concentrated sulfuric acid, which is nitrate radical. Then we are going to discuss the last group of the anions, which is the group of barium chloride, which are two anions, sulfate anions and phosphate anions, that has no acids more stable than them, so we use barium chloride solution to detect them. So let us start. The nitrate anion, the main test. Again, my dear student, the main test must be done on the solid salt. So solid salt plus concentrated sulfuric acid, and heat is needed. Here the observation: the brown vapor of nitrogen dioxide gas is produced due to the decomposition of the produced nitric acid, which increases by adding excess copper turning, as the following animation show. Here, my dear student, the sulfuric acid concentrated added on the solid salt. We see here the nitrogen dioxide gas produced, and adding copper turning, the brown fumes are increased. The equation of the reaction: sodium nitrate, which is solid salt, adding concentrated sulfuric acid, which is liquid, it gives here the sodium sulfate solution, and nitric acid is produced. Then nitric acid is decomposed by heat, giving nitrogen dioxide gas, which is reddish brown fumes, releasing water and oxygen gas. Here, when we add copper turning, copper powder, on the concentrated nitric acid, what happens? Here, copper nitrate is produced, water and nitrogen dioxide gas, which is reddish brown fumes. The confirmatory test. Here the salt solution plus freshly prepared concentrated solution of iron 2 sulfate. My dear students, now the confirmatory test of the nitrate anion, we have to use iron 2 sulfate. We have to use freshly prepared iron 2 sulfate. Why we use freshly prepared iron 2 sulfate? As we know, iron positive 2 is easily oxidized into iron positive 3 to be more stable, as it has half-filled D sublevel. So we have to use freshly prepared iron 2 sulfate in this experiment. So we are going to continue the experiment. Look at the screen again. The salt solution plus freshly prepared concentrated of solution of iron 2 sulfate, then add few drops of concentrated sulfuric acid on the internal wall of the tube. What do you observe? A brown or black ring appears at the interface and disappears by shaking or heating, as the following animation show. Here, my dear students, we bring the salt solution, and we are going to add here iron 2 sulfate, which is freshly prepared, on the solution as shown on the screen. Then we add concentrated sulfuric acid on the internal walls of the tube as shown on the screen. We know that the sulfuric acid has higher density. فبالتالي the density of sulfuric acid make it sinks down، بيبقى ينزل تحت خالص sulfuric acid، وهنلاحظ ظهور the brown ring at the interface of the tube. This brown ring will be disappeared by heating or shaking the tube as shown on the screen. So the equation of the reaction: iron 2 sulfate aqueous solution plus sodium nitrate aqueous solution plus sulfuric acid aqueous solution. Here it gives iron 3 sulfate and sodium sulfate and nitric oxide gas and water. Here, my dear students, sulfuric acid is oxidizing agent. So oxidize iron 2 sulfate into iron 3 sulfate. And it is here reacting with here sodium nitrate, giving sodium sulfate, and nitric oxide and water are produced. Here the iron 2 sulfate reacts with the nitric oxide gas which is produced, forming the black ring compound FeSO4.NO. We have give reason in this point. Hydrochloric acid is not used to detect the anions of the group of the sulfuric acid. Why? I told you before, because the hydrochloric acid is less stable than the acids of these anions. So it doesn't react with their salts. Another give reason in this point, concentrated sulfuric acid reacts with the salts of the anions of the hydrochloric acid group. Why? Because the sulfuric acid is more stable than the acids of these anions, so react with their salts. أعزائي الطلبة، احنا دلوقتي قلنا إن group of dilute hydrochloric acid contain carbonate anion, bicarbonate anion, sulfite anion, thiosulfate anion, sulfide anion, nitrite anion. Groups of concentrated sulfuric acid اللي هم chloride anion, bromide anion, iodide anion, nitrate anions. احنا هنا بنقول ان ما ينفعش dilute hydrochloric acid يعمل detection للanions of group of sulfuric acid. ليه؟ لان dilute hydrochloric acid less stable than the anions of the group that be detected by sulfuric acid. ولكن ينفع السلفوريك acid يعمل detection للanions of group of dilute hydrochloric acid لان هو more stable عن الanions بتاعتها. فاضل عندنا مجموعة واحدة هنتكلم عليها في detection of anions اللي هم مين؟ الفوسفات والسلفات. الفوسفات والسلفات these anions have no acids more stable than their acids. عشان كده بنستخدم باريوم كلورايد عشان يعمل لهم detection. يبقى دلوقتي هنستخدم الباريوم كلورايد to detect sulfate anion and phosphate anion. So look at the screen again. The anions of barium chloride solution. It includes the following anions: phosphate anions and sulfate anion. We have give reason in this point. Barium chloride solution is used to detect the above anions because the salt solution of these anions give colored precipitate with barium chloride solution. Another give reason in this point. Both of hydrochloric acid and sulfuric acid are not used to detect the phosphate and the sulfate anion. The reason for that, because both of hydrochloric acid and sulfuric acid are less stable than the acids of these anions, so they don't react with their salts. طيب احنا هنتكلم دلوقتي على الفوسفات anion. Main test. Here salt solution plus barium chloride solution. The produced precipitate here is white precipitate of barium phosphate, which is soluble in dilute hydrochloric acid as the following animation show. Here we use here sodium phosphate for detection of phosphate radical. Here solid salt, and then we are going to add here water, distilled water, to make salt solution of sodium phosphate. Then we are going to add barium chloride solution on this solution. What happens? As you see, white precipitate is formed of barium phosphate. Now we detected the phosphate anion. The equation of the reaction, sodium phosphate plus barium chloride, it gives here sodium chloride and barium phosphate. Here all of these salts are aqueous solution except barium phosphate, which is solid precipitate, which is here white precipitate. The confirmatory test. The salt solution plus silver nitrate solution. The produced precipitate is yellow precipitate of silver phosphate, is formed that's soluble in ammonia solution and in nitric acid, as the following animation show. Here we use the salt solution of the salt and then the adding silver nitrate solution over it. Here what are you going to show? Here the yellow precipitate of silver phosphate. This yellow precipitate of silver phosphate, if you are going to add ammonia or nitric acid on it, it will dissolve. So the yellow precipitate here dissolve in ammonia solution or nitric acid, as shown on the screen. The equation of the reaction: sodium phosphate plus silver nitrate, it gives sodium nitrate aqueous solution and silver phosphate, which is solid, which is yellow precipitate, which is soluble in ammonia or nitric acid. Sulfate anion. Here the main test: the salt solution plus barium chloride solution. What happens? Here it gives white precipitate of barium sulfate, which is insoluble in dilute hydrochloric acid. Here we use the salt solution of sodium sulfate. We bring here by the spatula some of the salt in a clean test tube, as shown on the screen. Then we are going to add distilled water to make salt solution. Then after stirring, we have to add barium chloride solution, as shown on the screen. What do you observe? Yes, the observation here is the formation of the white precipitate of here the barium here sulfate. My dear student, remember barium sulfate and barium phosphate, both of them are white precipitate. To differentiate between them, we are going to add dilute hydrochloric acid. It dissolves only the barium phosphate, while barium sulfate will not dissolve in dilute hydrochloric acid, as shown on the screen. So the equation of the reaction between barium chloride and the sodium sulfate, as shown on the screen, they give here sodium chloride solution and white precipitate of barium sulfate. The confirmatory test: the salt solution plus lead acetate solution. Here the precipitate formed is white precipitate. Here is the salt solution of the sulfate, and here we add the lead acetate. It gives here white precipitate, as shown on the screen. The equation of the reaction: sodium sulfate plus lead acetate, as shown on the screen. What happens here? They give sodium acetate and lead sulfate. My dear students, in your syllabus, sulfate precipitates are white, sulfide precipitates are black, so you have to know this information. أعزائي الطلبة، احنا دلوقتي استخدمنا سيلفر نيتريت سوليوشن بيعمل ديتكشن لاناينز للسلفايت والسلفايت في جروب الدايليوت هيدروكلوريك اسيد، وعمل ديتكشن للكلورايد والبرومايد والايودايد فين في مجموعه السلفوريك اسيد، وعمل ديتكشن للفوسفيت اناين اللي هو فين في مجموعه الباريوم كلورايد. طيب احنا خدنا ان هو بيعمل وايت بريسبتد مع مين؟ مع السلفايت اللي هو الاس او 3 نيجاتيف 2 ومع الكلورايد. بس ايه الفرق؟ ان احنا قلنا مع السلفايت بيعمل وايت بريسبتد تيرنز بلاك باي هيتنج، لكن مع الكلورايد كان بيعمل وايت بريسبتد، ده بيتحول لفايلوت في السنلايت، وكمان كان بيدوب في الامونيا والنيتريك اسيد سوليوشن. خدنا كمان ان السيلفر نيتريت بيعمل يلو بريسبتد مع حاجتين، مع الفوسفيت وكمان كان بيعمل مع الايودايد. بس ايه الفرق؟ ده نعمل ديفريشيت بتوين ذم، ان هو كان مع الايودايد ما كانش بيدوب في الامونيا ولا النيتريك اسيد، ولكن كان بيدوب مين؟ اليلو بريسبتد اوف سيلفر فوسفيت في الامونيا والدايديو والنيتريك اسيد اللي احنا كنا بنستخدمه. يبقى احنا عرفنا دلوقتي ان السيلفر نيترايت بيعمل ديتكشن لكام اناين؟ لستة. ايه هما الستة دول؟ اللي هما السلفايت اللي هو الاس او 3 نيجاتيف 2، والسلفايد اللي هو اس نيجاتيف 2، والكلورايد اين اللي هو سي ال نيجاتيف، والبرومايد اين بي ار نيجاتيف، والايودايد اين اللي هو اي نيجاتيف، وكمان اخدنا الفوسفيت اناين اللي هو بي او 4 نيجاتيف 3. دلوقتي هنحل بقى شويه اسئله على الجروب بتاعت الاناينز اللي هي مجموعه الهيدروكلوريك اسيد والسلفوريك اسيد والباريوم كلورايد. Let's start. Questions. Choose the correct answer. Solid salt plus dilute hydrochloric acid gives reddish brown fumes at the mouth of the tube. Is that radical nitride or nitrite or nitrate or sulfite? If you think about it, yes, it will be nitrite. Next one. Solid salt plus dilute hydrochloric acid gives gas turns paper wet with acidified potassium dichromate bisulfuric acid from orange to green. Is it sulfite or sulfate or nitrate or nitrite? If you think about it, yes, the answer it will be yes, sulfite. Next point. Salt solution plus potassium permanganate acidified by sulfuric acid, the violet color is decolorized. Here the radical is nitrite or sulfate or nitrate or sulfite. If you think about it, yes, the answer is here nitrite. Next one. Salt solution plus silver nitrate solution produce yellow precipitate that insoluble in concentrated ammonia solution. Is it iodide or nitrate or phosphate or bromide? If you think about it, yes, it will be iodide. Remember, my dear student, silver nitrate give yellow precipitate with iodide and phosphate, but it is insoluble only in case of iodide. Next one. Solid salt plus concentrated sulfuric acid gives orange red fumes that turns paper wet with starch to yellow. Is it chloride, iodide, bromide, nitrate? If you think about it, yes, it will be bromide anion. Next one. Solid salt plus concentrated sulfuric acid gives gas that forms white fumes with paper wet with ammonia solution. Is that radical bromide or chloride or iodide or nitrate? If you think about it, yes, it will be chloride ion. Next one. Solid salt plus concentrated sulfuric acid gives violet fumes that turns paper wet with starch to blue. Is it chloride, bromide, nitrate, or iodide? If you think about it, yes, it will be here iodide. Next one. Solid salt plus hot concentrated sulfuric acid gives brown fumes that increase by adding excess copper turning. What is this radical? Is it nitrate, chloride, bromide, iodide? Yes, if you think about it, yes, it will be nitrate radical. Next one. Salt solution plus silver nitrate solution produce white precipitate, turns violet in sunlight. Is it iodide, nitrate, bromide, or chloride? If you think about it, yes, it will be chloride anion. Next one. Salt solution plus silver nitrate solution produce white yellow precipitate. Is that radical bromide or nitrate or chloride or iodide? If you think about it, yes, it will be bromide anion. Next one. Salt solution plus barium chloride solution produces white precipitate insoluble in dilute hydrochloric acid. Is it phosphate or sulfate or nitrate or nitrite? If you think about it, yes, the answer it will be sulfate radical. Next one. Salt solution plus lead 2 acetate solution produce white precipitate. What is the radical is? Is it phosphate or nitrate or sulfide or sulfate? If you think about it, yes, the answer it will be sulfate radical. Next one. Salt solution plus barium chloride solution produce white precipitate soluble in acids. What is it? Is it phosphate or sulfate or nitrate or nitrite? If you think about it, yes, the answer it will be phosphate radical. Next one. Salt solution plus silver nitrate solution produce yellow precipitate that soluble in concentrated ammonia solution. Is that radical iodide or sulfate or chloride or phosphate? Yes, if you think about it, yes, it will be phosphate. I told you that yellow precipitate with phosphate and iodide, but it's soluble in ammonia solution with phosphate only. Next one. Salt solution plus silver nitrate solution produce yellow precipitate that insoluble in concentrated ammonia solution. Is it bromide or phosphate or chloride or iodide? Yes, all of you know the answer now, so it will be iodide radical. Graph question. The opposite figure express the change in mass of the formed precipitate on adding solution of what to solution contain anion of what, then adding concentrated ammonia solution to the reaction mixture. Here the volume of added ammonia solution, as you see that the precipitate is formed, then dissolve partially. So here, yes, if you look at the choices here, barium chloride and iodide, or silver nitrate and chloride, or barium chloride and phosphate, or silver nitrate and bromide, which one which will be white yellow precipitate that slightly soluble in ammonia? It is bromide. So the answer is silver nitrate and bromide anion. How to differentiate between sodium phosphate and sodium sulfate? Here's the experiment. Salt solution plus barium chloride solution. If white precipitate is formed soluble in dilute hydrochloric acid, it is sodium phosphate. As the equation proceeds, sodium phosphate plus barium chloride gives barium phosphate and sodium chloride. Here the white precipitate is here barium phosphate soluble in dilute HCl, while the white precipitate which is formed, which is insoluble in dilute hydrochloric acid, is sodium sulfate. Here the equation sodium sulfate plus barium chloride gives barium sulfate and sodium chloride. Here barium sulfate is white precipitate which is insoluble in dilute hydrochloric acid. My dear students, we have reached to the end of our program today. I hope you understood all the points and experiments that we have discussed today, and till we meet again, my best wishes.